So last section we're going to look at this week is 3.6, and we're going to take a look at what's called transformations of functions. So it's taking something that you already have and just kind of moving it somewhere else or making it look a little different. Right? So I'm going to give you a definition of two transformations that we're going to do today, and I'm going to show you a picture, and I think it'll make sense what it is. So the first one is called a translation. Or you can also say shift. It means the same thing. All right, so on your guided notes, you have a blank, and it says a translation is a transformation that shifts a graph horizontally or vertically, but that's it. It doesn't change the size, the shape, or the orientation, which means how it's turned or something like that. So that's an example what I have on the board of a translation. The triangle in red and the triangle in blue. All you've done is you took the one that's in blue and you moved it up. Well, actually, this one went up exactly 1, 2, 3, 4. Everything went up 5, and then it went left 4. That's what they did in this one. They pushed everything up 5 and left 4, and then redrew the exact same picture. That's called a translation. Any question on that? All right, so pretty simple.
Translation to like a slide. You slide like up to the right, down to the right, down to the left. It's sliding.
So the next one we're going to look at is a reflection. So a reflection, think of that as like a mirror image, right? A reflection is a transformation that flips a graph over what's called the line of reflection. Okay? Or it's like a mirror. It's like a mirror line. So here's an example of a reflection. If you pretend like this was a piece of paper and you folded the piece of paper right on that mirror line, what's on the left would land exactly what's on the right. Right? It's a mirror image. Right? You couldn't just take what's on the left here and slide it to the right and have it look the same. Okay? What's on the left and what's on the right are mirror images. Now there's a couple ways you could fold this, right? You could fold it this way, or you could fold it the other way. So there's two types of reflections we're going to look at. Reflecting it left to right, which is horizontal, or reflecting it up and down, which is vertical. All right. So what we're going to give you guys up front is all the different transformations we're going to do. There's 8 different ones. So we're going to give you a chart so that when we go through and do a problem, we're going to go back and look at the chart and figure out, oh, okay, we added a number at the end. What does that mean? Or we added a number inside parentheses. What does that mean? All right, so we're going to give you a chart that explains all of them right now. And then all the examples are going to be at the end.
So you're going to go back for more.
All right, so whenever you want to graph something new, right, first thing we have to do is make a table with 3 points for the original graph. And we're going to try to pick numbers that are easy to work with to make these points. Okay, I can't always say what they'll be. It depends on the problem, but we're going to try to pick numbers that are easy. So the goal is we're going to figure out where 3 points are, and then we're going to figure out where those 3 points move to in our new graph. And how they move depends on what you do. Did you shift them up or down? Did you do a mirror image with them? Like what did they tell you to do in the problem?
Guys, sometimes we may not always ask you to graph it. We might just say, based on how it's written, what it looks like, describe the transformation. So you're not always going to have to graph it.
So the first 4 things we're going to look at are all going to have to do with vertical. Okay, they're all going to have to do with things that affect the graph up and down. Okay, and the first one is a vertical stretch. So on
you can see above each thing. That's what you have to write.
So on your chart, it says problem written like, and you're going to put number times f of x. So this is going to be an example where you would have a number in front times f of x.
Okay, we need a dot between number and f of x.
No, that's okay.
Show multiplication, okay, all right.
So you might have something like this. It would look exactly like that. 3 times f of x, or 5 times f of x, or any number. Yep. You'll have a number in front. Anytime you put a number in front, what that's going to do to your graph under type of transformation is it's going to stretch it, right? So if you had something like this, the letter M, and you stretched it, it would, can I do it? You know what I can do? I can do it like this, maybe. Let's say I had a circle, and then I decided to stretch it vertically. It would do that to it. That's a vertical stretch. You distorted it. It doesn't look the same anymore because you stretched it out. Right? That's a vertical stretch. So, how would you graph it? So in the next column, where it says how to graph, you would take all the y values and multiply them by a number. How would you know what number? Well, you just look back at the problem. Whatever number they put in front. So you multiply the y values by a number. Okay? We're going to have 4 transformations on this page. Every single one of them is going to affect the y values. Vertical. Okay, this is all vertical stuff.
The y-axis goes up and down, it's vertical.
And when you're asked to describe what happened, you would say, like, if I asked you to describe what happened to my circle, it doesn't look like a circle anymore. What happened to it? It's been vertically stretched by factor of the number. So I might say, well, that's been vertically stretched by a factor of 3. It's been stretched out 3 times as much, and it's distorted. Doesn't look like a circle anymore.
Is it different, like, words to describe, like, the way you, like, move them? Like, you know how, like...
So there's going to be 8 different phrases like this.
Oh, okay.
Vertical stretch by a factor of something. Yeah, yeah. Okay, that's our first one. Okay, next one. This is where you're adding a number outside the parentheses, right? On to the end. So that might be something like f of x plus 2. There's a plus 2. So when you have a function, could be f of x, g of x, could be any function plus a number. That shifts your function up. So this time it doesn't distort it. It just takes exactly what you have and moves it up. So what this is going to do is, because you're shifting it up, remember again, up and down is the y-axis. You're going to add a number to all the y values. How do you know what number to add? Well, you look back at the original problem. 258. And the way you would describe this, so if that was your original picture, and you did this to it, 1, 2, the way you would explain what you did to someone is you would say, shift up number units, shift up 2 units, shift up 5 units, shift up 8 units, right? And you're not going to have to memorize all this stuff. All you got to do is write it down in your chart, and then when you get a problem that looks like this, go back and look at your chart and say, okay, which one is this? Is that a stretch? No, he didn't multiply by a number in front. Oh, he added a number. That's when you shift up, all right? So this is just going to be like a reference, and you're going to look back at it. Yep.
That's my question. If you can have
Yep, you can have this on the
It's
test.
actually already, you just got to copy it onto the reference sheet, that's all. It's already on the reference sheet, you just got to copy it back down.
Okay, this one, very similar to the last one. In fact, you could even almost put them together, but we wrote them separate. F of x minus a number. Well, plus a number shifts up, minus a number would shift down. So it would look something like f of x minus 5. That would take whatever you had before, which is f of x, and it would move it down 5. Wouldn't stretch it, wouldn't mirror image it, it would just take it and move it down 5. So this time, to calculate your coordinates, if you were going to graph it, you wouldn't add a number to all the y values, you would subtract number from all the y values. What's the number? Well, you look back right there. So in this case, it says subtract 5 from all the y values. And there's one more transformation we're going to talk about that affects the y values. What was the second thing I did on the first page? Not the translation, but what was the other one? A flip, right? A reflection, right? A reflection. So that's going to be the last one we look at. A flip. And the way you would describe it, so if you had something like this, and your new one looked like this, 1, 2, 3, 4, 5, you would say to somebody to describe it, I shifted down 5 units, or I shifted down 2 units. That's how you describe it. And you don't have to say it exactly like that. If you said I translated down, that's a fancier way. You could say translate down 5 units. Translate and shift mean the same thing.
Move down 5 units.
Yep. All right, so the last one we're going to look at is a reflection, right? And it's vertical, right? We did a vertical stretch, we did vertical shift up, we did vertical shift down. Again, this is all vertical. That's why it's all together. This is your vertical reflection. All right, so let me show you what that would look like. If I had a picture like that, and I wanted to do a vertical reflection, that means I'm flipping vertically, up to down, up to down. So what that's doing is, if you pretend right here that's a fold, and you fold that piece of paper right on that line, it should look something like that. That's a vertical reflection. If I folded it right along that horizontal line, the top triangle would land right on the bottom one. So it doesn't really stretch it. It doesn't like distort it. It just takes and makes a mirrored image of it. Right? And the way that one looks, it's a very, very small change, but it's important. It's right there. It's when you put a negative in front of your function. Negative in front of your function. So something like this. I'm just writing it bigger. Negative f of x. Right? That tells you that it's a reflection. So when you reflect it, what happens is everything that was on the top becomes on the bottom. So it means just make all your y values the opposite. You don't do anything to the x values. You just make all the y values opposite. And the way you describe it, there's a couple ways. You can say, I heard someone say flip earlier. Flip is fine. Or reflect over the x-axis. Either way. X, that's your y. Not every single one of these, well, a lot of them are going to be on the test, but not all of them. You're going to have some shifts, you'll have some stretches, but this is going to be like your guide that all you got to do is look back at it, match up the problem you have with what's in one of these rectangular boxes, or in your case, what's under the problem written like column. Now, look at all the boxes I have, and I want you to kind of look for a pattern. The first one I multiplied by a number. Was that inside the parentheses or out in front? Out in front. It was outside the parentheses. I added a number. Is it inside the parentheses or outside?
Outside.
Outside. I subtracted a number. Is it inside the parentheses or outside?
Outside.
Outside. I put a negative. Is the negative inside the parentheses or outside? Outside. That's the pattern with vertical stuff. It's all outside the parentheses. So the next page is going to be horizontal stuff. Where do you think we're going to do stuff now? If before we did it outside the parentheses, what's going to happen now? Inside the parentheses. So we can do all these same things again. We can multiply by a number. We can add a number. We can subtract a number. We can put in a negative. Except now we're going to do it inside the parentheses. And that makes it a horizontal instead of a vertical. Right? So it's kind of like we're going to do the same 4 things again, except now everything is going to affect the x values. We're going to move left and right, or stretch left and right. I think stretch is the first one we start with. So now it says number times x. Right? So that would be something like f of 2x. That's an example of a stretch. Anytime you multiply by a number, it's a stretch. The only difference is, did you multiply inside the parentheses or outside? Inside is always horizontal. Outside is always vertical. So 2x, that's a horizontal stretch, so put that under type. How to graph it. Now, everything here is going to affect the x values. Right? On the previous page, it was all y values. Now it's all x values. And the way you describe it, again, you've got to kind of stick with this wording because it's a little tricky right at the end here. The way you describe it is you say horizontal stretch by a factor of not your number, but it's 1 over your number.
It's like a fraction.
Yeah, it's a fraction. So this, if I was going to describe this to you, I would say that's a horizontal stretch because I'm multiplying by a number inside. And I would say horizontal stretch by factor of 1 over 2. So horizontal stretch by 1/2. That's what I would say. All right. And that's why I put this in quotes, because it's put that out, because it's a little tricky to remember that it's 1 over. It's just the way it works. All right, so we did a stretch. What's the next 2 things that we did when we did the vertical stuff? After the vertical stretch was what? Shift up and down. Well, horizontally, we don't have up and down. What do we have? We have left and right. So now we're going to add a number. We already did this. We added a number. But the difference here is, look now, it's inside the parentheses. It's not outside. So this would be something like f of x plus 4. Okay. Well, I look at it and I say, all right, it's inside the parentheses. Inside means horizontal. It's addition. Addition always means a shift. Always. If you add outside, it's a shift. If you add inside, it's a shift. You just have to figure out which way. In this case, adding a number shifts left. And that's a little weird, because if you think of a number line, the positive numbers go in which direction? They go right. Well, it's just that's how it works. Even though this is a positive number, you might think, oh, positive numbers, the number line goes to the right. You got to remember it shifts left. Okay, so plus inside shifts left. And the way you handle that one is you subtract the number from all the x values. You're going to kind of notice that all the horizontal stuff is like backwards from what you would think you do. The vertical stuff is pretty much what you see is what you do. There's not too much tricky about vertical. But horizontal, it's like everything is backwards. That's just how it works. But again, you don't really have to remember, as long as you copy this correctly. You just go back, look at it, just follow the directions. And the way you would describe this is you could say shift left or move left. 5 units, 6 units, whatever it is. Okay, so we got 2 more, and then we're done with the chart. Right? And then we'll do one more thing, and then we'll start looking at some examples. All right. So we did x plus a number. What do you think x minus a number would do if it's inside the parentheses? Shift it. Well, that's left. We got that one. It's going to shift it right. So x minus a number shifts it right. Again, kind of the opposite of what you would think. Negative numbers go to the left, but just remember this. So that would be like f of x minus 4. That's a shift right 4 units. All right, so if you're going to graph it, you're going to look at your original coordinates, and you're going to add a number to all the x's. What number are you going to add? Whatever number is right there. So in this case, add 4. Okay, and this one's pretty straightforward. Again, like the last one, how you pronounce it or say it to someone. You just say shift right 5 units or move right 2 units. And the last one. When we did the vertical, what was the last thing we did? A reflection. And it was a vertical reflection. Well, this isn't going to be a vertical reflection. This one's going to be a horizontal reflection. That's like what I have in the first page. I think I had a picture of that one right here. That's a horizontal reflection. You flipped left to right, left to, or right to left. Either way, but you flipped left to right. And what did you have to do? It was a very small thing. But what did you have to do to reflect something?
Doesn't have to have.
A negative sign. When you did it vertically, where was the negative? Inside parentheses or outside? It was outside. Well, now we're going to put it inside. So whenever you put a negative in front of something, it causes a reflection. If you put it outside, it's a vertical. If you put it inside, it's a horizontal. So a horizontal, if I wanted to draw it, just drawing it with triangles because that's easy for me to do in my head. That's a horizontal reflection. It flipped. Flipped right over your y-axis. All right, so to flip it, if you have to graph it, you're going to take your original coordinates and you're going to make all the x values opposite. So in the last one, we made all the y values the opposite in the last reflection. This time it's all the x values. In the way you pronounce it or say it, it was all pretty much in the description up above. It's a reflection, or I think somebody used the word flip. Well, a lot of people say flip, that's fine. Flip over the y-axis. So now we just listed a lot of transformations. Right? We talked about shifts, stretches, reflections for horizontal and for vertical. Now, when you do arithmetic, right, there's a certain order you have to do it in. Right? PEMDAS. You can't just do it in any order you want and it'll work, right? You got to follow a certain order. Well, if you have a problem and I ask you to list the transformations, you can't just list them in any order you want. Okay, I gave them all to you, but you can't just say, oh, you do this, then that, then that. No, there's a certain order you have to list them in, and that's the order I'm going to give you right now. Not every problem has every transformation in it at the same time. That'd be crazy. That'd be like a problem like this. Negative 2 times 4x plus 6 minus 8. All right, that's got all kinds of stuff. It's got addition inside, it's got subtraction outside, it's got multiplication inside, it's got a negative outside. There's a lot of stuff there. On a test, you might see something like that. It's got two things. It's got addition inside and it's got multiplication inside. And that's it. Just got two things. So when you list your transformations, and this is right at the bottom of your front page, the first one you always list, if it's there, is a horizontal shift. This one does have a horizontal shift. It's right there. You could go back in the notes and look up what adding a number inside does, but I'm telling you it is a horizontal shift. The next thing you would do, if you have it, is a horizontal stretch. This problem does have a horizontal stretch. I just circled it right there. And you could go back in your notes and look what multiplying inside does, but I'm telling you when you multiply inside, that's a horizontal stretch. The next thing you would do, if you have it, is a horizontal reflection. This one doesn't have a horizontal reflection. How do I know that? Horizontal, any reflection has a little negative. There's no negatives in this whole thing. So there's no horizontal reflection. There's your horizontals. The next thing you do is you list all your verticals, but they have to be in a certain order. You start with a vertical stretch, if you have it. This problem doesn't have it. Vertical is when you have stuff outside the parentheses. There's nothing outside the parentheses in this problem. Everything is inside. So there is no vertical stuff in this problem at all. After you do your vertical stretch, then you would do your vertical reflection, if you have it. How would I know if I have it? I'd have a little negative, and it would be on the outside of the parentheses. This problem doesn't have it. And then the last thing I would do is my vertical shift. Again, this problem doesn't have it. A vertical shift is when you add or subtract a number outside parentheses. There's no adding or subtracting outside parentheses here.
Steve, you think it might be a good idea on that chart to go through and have a little space on the left-hand side? Maybe number them?
We could after maybe.
After, okay.
Yeah.
Well, guys, tonight when you have to copy it down the reference sheet, you might just want a number on the out because you're not going to have the order of how to describe them. So when you do it on your reference sheet tonight, you may want to put on the left-hand side just 1 through 6 next to each one so you know.
Yeah, because you have two shifts, so you'd have to number them with the same number.
Yeah.
Shift up and shift down would be the same number. All right, so let's look at some examples. So that's as far as notes, like new information, like that's it. Now we're just going to look at that chart and try to figure out what's going on. All right. So first thing, yeah, it might have been helpful to have them like side by side, so you didn't have to. But we photocopied it double-sided, so it's fine. All right. So they asked us first to graph this. This goes back to yesterday. What's the y-intercept in that f of x? -1. So we're going to put it out on -1.
You got to remember, f of x means the same as y equals. F of whatever, g of whatever, it doesn't matter. It still means y.
What's my slope there? 2. Now it's not a fraction, so how could I make it a fraction?
Over 1.
Over 1. So what does that mean? From the y-intercept, which way do I go?
Up to.
Up to?
Over 1.
Over
The right.
to the right. Yep. Up to right 1. Up to right 1. Okay, I just did it a bunch of times. Now I'm going to make my line. A little off. Good enough. Okay. So now they want us to graph this. My original function with a +3 on the outside. Does anybody remember or look back at the chart? What is a +3 on the outside going to do? Yusef? Yep, up how many? It's going to go up 3. So keep that in mind. We're going to draw a new picture, and it should look like the black one, up 3 units. All right. So now, what I have to do is I'm going to write down 3 coordinates that are on that line. I really could just do 2, but we'll do 3.
Question.
Yeah.
Let's do it. Is it 3 or?
I would do 3, because you're only going to have one graph and one on the test.
Oh, just one?
Yeah.
Yep.
All right, so let's look a little closer. Can somebody give me a coordinate, and I marked a bunch of them, that is on that line? You could name any one of those black dots that I have.
Y-intercept's okay too, right, Mr. Hager?
Yes.
Okay, Mr.
Yep, that's one of my dots.
0, -1.
0, -1. All right. That's one. Somebody give me another coordinate that's on that line. Yep, 1, 1. That looks good. And one more coordinate. This is just like an extra check. Matt?
2, 3.
2, 3. Perfect. Now, I have to get the new coordinate. So we got to go back to our chart and look what the directions are when you add a number on the outside.
Yeah, so now in that column, you want to get the coordinates so you can graph it.
What is the directions? So it's right here. When you have that, what am I supposed to do? And what values do I do it to? The x's or the y's? You said?
No Y's.
And what am I going to do to the y's?
Add numbers to all Y values.
Add number to all y values. All right, let's look. What's my number here?
For the first one?
In the original, in like this, what they're telling me to do right here.
Oh.
Gigi?
3.
3. They're telling me to add 3 to my original function. And Yusef just said you add it to the y values. So let's do it. X's stay the same. Might as well just copy those all down. Now we're going to do +3 to all the y values. What's -1 + 3?
+2.
+2. What's 1 + 3?
4.
4. 3 + 3.
6.
6. There's 3 points that are on your new graph. Let's see what it looks like. Now remember, it should have gone up 3. So we've got 0, 2. We've got 1, 4. And we've got 2, 6. 2, 1, 2, 3, 4, 5, 6. Let's make a line in red through those points. And does it look like the line, let me make it red, the line in red moved up? Yeah, it moved up. If you took the line in black and you went 1, 2, 3, it would go up 3. Just look at any of those red dots and look at the black dot right below it. Up 1, 2, 3. Up 1, 2, 3. Up 1, 2, 3. All the black dots went up 3. Perfect. Right? Let's look at this one. It's kind of it's a different example, but it's the same same starting function. You're adding 3 again, but it's what? You're adding 3 again, but it's different. You're adding 3 inside.
That's where it gets tricky.
So let's go back to our chart. You've added inside. Can someone tell me where that is? Yep, Yusef?
Horizontal shift left.
Yes, it's right here. Adding a number inside is a horizontal shift left. All right, so keep that in mind. That's the one we're going to be using this time. So we'll come back to the directions in a second. First thing I need is 3 original coordinates. I already have them. We're doing the black line again. So it's the same one. You can forget about the red line for now. The red line was a different problem. We're done with the red one. So let's use the same original coordinates from the black line. And now, let's go back to the directions. We've added inside. Youssef told us it's a horizontal shift left. What are the directions? What do I do, and what value, what letter do I do it to? Youssef?
Subtract the numbers from all x values.
Subtract number from all x values. All right. Subtract. There's my number right there.
The y's just the same.
The y's are going to stay exactly the same.
It's the opposite now, so now we're dealing with the inside.
So subtract number. Alex, what's the number I'm using here? 3. I'm going to subtract 3 from all the x values. What's 0 minus 3? 1 minus 3. 2 minus 3. Okay. I'll do this in, I'll do it in green. So let's graph those new coordinates and see what it looks like. -1, -2, -3. -1. -2, 1. -2, 1. -1, 3. -1, 3. Let's make my line in green. A bit, that's okay. Not perfect, good enough. Right. Now, if you look at the line in black and the line in green, does it look like the line in green moved left 3 units? What do you think, Dylan?
Yeah.
Yeah. Look at the black dots. 1, 2, 3. 1, 2, 3. 1, 2, 3. They moved left. Every black dot moved left 3 units. So I've said it a bunch of times, but let's write it down. What just happened? So for part A, let's see. We said that was we said shifted up 3 units. So write exactly that. You know what? I'll just put it. I'm just gonna put it right next to the original problem. Do you guys have room? You could put it right there.
Yep.
All right. Let's just write it right there. So shift up 3 units.
So we asked you to describe it, guys. That's how you would describe it. That's it.
Shift up 3 units.
I mean, doesn't it say on the graph too, like the
What's that?
table thing? Doesn't it say like how to say
It says that right on the table.
It does.
Yep. Shift left, whatever units. Shift right, whatever units. Yep, I'm getting that right from your table. And then the +3 inside, we said that moved it. Inside is the opposite, so it's left 3 units. So let's put it, that's f of x in part A, and then right here next to part B, shift left 3 units. That's how you describe it. Again, only one problem where you have to graph. Most of them on the test are just describe. We might do one more graph today, but I want to make sure we get through some more describes, which I think we will. Okay. This would also be 2 problems on a test. You're not going to have to do a part A and a part B in the same problem. Like, I would get rid of part B and just put part A on the test, or vice versa.
Well, yeah, you have to graph the original that we gave you, like the 2x minus 1, and then graph another one.
Okay, so this one, example 2, just a single one this time, not a double graph. So let's start by graphing the original. What's my y-intercept on f of x this time? 1. Okay, and someone besides Youssef, you're doing great, but someone else tell me what's my slope? Yep, Miguel? 1/2. So can you tell me from the y-intercept, what do I do to get another point?
You would go up 2,
Up how many?
2,
1, right? This is my rise, so up 1,
and then go over to the right 2.
and then to the right 2. So up 1, right 2. Up 1, right 2. The reason I'm doing it a few times is so that when I write my original coordinates, you can pick any one of those dots I just did. Okay, let's put our line in there. About like that. Okay, now I need to name 3 original coordinates. So we need to pick 3. Doesn't matter. Just pick 3 that look pretty simple. Y-intercept is probably a good one. Somebody give me one coordinate that's on that line. Yusuf?
0, 1.
0, 1. Nate, can you give me a second coordinate?
Three and 2.
Not 3, 2. 3, 2 would be over here.
3, 2, 2, comma
2, 2. Yep, that's a good one. And Nicole, can you give me one more? 1, 2. 3, 4 would be up over here. 4, 3. All right. Now we've got to get the new coordinate. Well, look at what they're having me do this time. They put a negative in front of it. Anytime you put a negative in front of something, what does a negative do? Savannah?
Reflection.
It's a reflection. Now, it's outside. So we got to go back in our chart and look where the negative is on the outside.
Vertical.
That's a vertical. Yes, that's a vertical reflection. So you know what? Let's describe it right now. Since we just said it, let's just say, how do I describe that? What do the directions say to how you would describe it? Yep, Joe?
Reflect over action.
Exactly. Reflect over x axis. All right, now I need the directions. What do I do to get my new coordinates? When I reflect vertically, what are the directions to get my new
Be able
coordinates?
to graph it.
You got to tell me what to do, and then you have to tell me what letter to do it to. Yep.
You make all y values the opposite sign.
Yeah. Make all the y values the opposite sign. So x's stay exactly the same. What's the opposite of 1? What's the opposite of 2? -2. What's the opposite of 3? -3. That's it. So graph those new coordinates, and that's going to be a mirror image. All right? So 0, -1. 2, -2. 4, -3. Let's make our line. Way off on that one. Okay, and the line in red is a mirror image. If you took and you fold, if this was a piece of paper and you folded it right along that line right there, this part on top would land exactly on that part on the bottom. What's on the top would flip to the bottom. What's on the bottom would flip up to the top. All right, so that's a reflection. Okay. Any questions on that one? Okay, so reflection is actually pretty easy arithmetic. You just have to put a negative. Just make sure you put it on the right number. So always look back at your chart. All right, let's. I think we have 2 examples left, 4 and 5, right?
Yeah.
Okay, we're doing good. Let's graph this one. What's my y-intercept? Yep.
1. -1.
-1. Yep. So always take the sign to the left of the number. And now my slope. What's my slope here? Donovan? 1. If you want to put it in, remember there's an invisible 1 in front of the letter. So my slope is 1. Brady, can you tell me from the y-intercept, how do I get to another point on that graph?
What's the slope telling you to do?
Up 1.
In what direction though? Up 1 and then left or right?
Yep.
You can do it.
Up 1, right 1.
Keep doing it.
Okay. That's plenty for original points. I don't need any more than that. All right. So there's my line. Now, look at what they're having me do. 1/3. What operation is that when you put a letter right next to a number?
Multiplication.
It's multiplication. So it's multiplication inside. So we got to look it up and see what that means. The fact that it's inside tells you something, and the fact that it's multiplication tells you something. Which one is this, Gigi?
Horizontal.
This is a horizontal stretch. Okay. So let's, did they ask us to describe it? Yeah. So let's describe it. What's the phrase to describe it? Horizontal stretch by, can someone finish that off for me?
By factor of 1 over the number.
Horizontal stretch by factor of 1 over the number. Horizontal stretch by factor of, what's the formula again? 1 over what?
1 over the numbers.
1 over, what's the number in this case?
3.
Well, that'll be the answer, yes. But
Okay.
what are they giving me here? What's the number? 1/3. Right? 1/3 is the number. So I'm just using my calculator to figure it out. 1 over the number. I type it in just like that. And it actually just comes out to 3. Okay. So this is a horizontal stretch by factor of 3.
If you have a whole number there, like 4 or -5, it would be 1 over whatever that number is. That's when it's happened to be a fraction.
Yeah, when you start with a fraction, your answer ends up as a whole number. When you start with a whole number, it ends up as a fraction. Just the way it works. All right, so we've described it. Now, original coordinate. I'll do the first one. 0, -1. Okay, can somebody give me another coordinate?
On that line.
Jacob, can you give me a coordinate on that line? Besides 0, -1. One, 1. Not quite. 1, 1 would be up here. But you could go right 1 and then 0. So you could do 1, 0. And how about one more? 2, 1. All right. Now I need to go back in my directions, look at the chart, and tell me what does it say to do when you do a horizontal stretch? Do what? Divide the x values by the number. So the y's are going to stay the same. Y's stay exactly the same. So now I'm going to divide my x values. Every x value is going to get divided by what? What is it you said? I can't hear you.
3.
3? No, 3 is not my number. What's the number in the original problem? 1/3. You're going to divide all your x values by 1/3. So we're going to type them all in. 0 divided by 1/3. Well, 0 divided by anything is just 0. 0. Next one. 1 divided by 1/3. Just dividing all my x values by that number. 3. Last one. 2 divided by 1/3. You always divide your x values by that number, and you get 6. Right, don't worry about doing the arithmetic by hand. Just use your calculator. Okay, let's graph them. So, first one stayed the same. Didn't change at all. And that's okay. That can happen. So 0, -1. But now the other ones are different. 3, 0, and 6, 1. Let's graph that line in red. Bless you. Right? And if you notice, that's a stretch. Imagine like it was glued in place at that red dot, right? And you pulled it, right? Like if you pull something, it flattens out, right? Like if I was really fat or something and you pulled me vertically and stretched me, it would make me thin. It would flatten me out. Well, same thing. You pulled it and it kind of started to straighten it out a little bit. So it's not perfectly straight like horizontal, but it's straighter than it was because it stretched out. Now, if you squished it, that would cause it to go taller. Like think about if you like squish me, right? You squish me together, and you get taller. I could use that. So, there you go. All right, so I think that's the last graph we'll do. Right? So now the next ones are going to be quick, just to describe. Okay, no graph here. All you have to do is describe. You're starting with this. They want you to do that. They put a 4 in front. You kind of already did this. You're multiplying and you're outside. So can anybody tell me what that's going to do? You're multiplying and it's outside the function. What is it? Yes, exactly. So how would you describe that? You said vertical stretch. Can you keep going? By a factor of, now what's the number here? 4. Perfect. Done. That's it. So when you don't have to graph it, it saves a lot of time. So it's a vertical stretch by a factor of 4. Any question on that one? Now, the only thing we haven't done yet is we haven't had a problem with multiple transformations in it, where you have to list them in a certain order. Okay, that's going to be the last one. Now, this is not one we would ever have you graph, okay, because there's a lot of things happening. But it is one where we would ask you to describe the transformations. All right? So look at this. Does anybody have a guess at how many transformations are happening? Well, there's definitely more than one. How many? Yes, there are 3 things happening. The +1 is going to do something, the 2 is going to do something, and the 3 is going to do something. So let's write them down. And we have to do them in a certain order. So let's go back to our order. There's 6 things to look for. What's the first thing you always look for? Horizontal what? Yes, horizontal shift. Look on your chart. Look what a horizontal shift looks like, and then look at this problem. Do you see a horizontal shift in this problem? What is a horizontal shift?
Horizontal, where are things happening? On the inside or on the outside?
Inside. Okay, I see stuff happening on the inside. Now it's a shift. What do you have to do to shift something horizontally on the inside?
There's 2 ways it could happen.
Left and right.
You subtract what?
You add or subtract. Do I have addition or subtraction on the inside here?
Yes, you do.
Yes, then I have a horizontal shift, and it's going to be controlled by that number right there. So it's a horizontal shift. How do I know if it's left or right?
If it's adding, like if it's adding,
It's this one's adding. So which way does adding move it?
to the right.
The left.
Left,
Remember, those horizontals, those shifts are a little tricky. Yes.
right? It's the opposite. So this is a horizontal shift left 1 unit. Everybody has that written correctly when you have plus, it's left.
That's opposite.
Okay? All right.
It's the right one.
Things happen on the inside when you're adding and subtracting the opposite.
Yes, you have to write 1 unit. You have to tell me what's happening and how much. If you just said this is a horizontal shift, you wouldn't get credit because you didn't tell me how much. Okay, horizontal shift, 1 unit, and now somebody tell me the last thing. What's the direction? Just make sure we get this right.
It's the opposite.
Left, yes, horizontal shift, 1 unit left. Okay, what's the next thing you look for after you horizontal shift? You look for a horizontal stretch. Now, look at your chart. Do you have a horizontal stretch in this problem? Nicole, what did you say? No. Horizontal stretch is when you multiply x by a number inside parentheses.
Inside, opposite.
We didn't multiply by a number inside in front of the x, so there is no horizontal stretch. So we skip it. What's the next one we look for? Horizontal reflection. How would you know if you have a horizontal reflection? You'd have a negative where? Inside. Do I have a negative inside in front of the x? No, I skip it. What's the next thing I look for? Vertical stretch. Do I have a vertical stretch here? Gigi, what do you think? Yeah, how do you know when something is a vertical stretch? You do what and you do it where? You multiply a number on the outside. I see that right there. 2 times, and it's on the outside. So vertical stretch by, and can somebody finish that off? How do you word it? Vertical stretch by factor of, and what number would I put? 2. The 2 is controlling the vertical stretch. All right, 2 transformations left to look for. What's the next thing after a vertical stretch? Vertical reflection. Do I have that? No. For a vertical reflection, I would need a negative on the outside, right next to the number in front. I don't have it. What's the last thing I look for? Vertical shift. Do I have that?
Yes.
Yes, vertical shift is when you add on the outside of the parentheses. I see addition on the outside. So vertical shift, and then what's the +3? Or you could just say move, vertical move, shift, same thing. The plus is going to move it which way? Up. How many? There you go. So once you get used to what to look for, it gets a little faster. Definitely wouldn't have to graph something like that. Just list it.
Yeah.
That's all you'd have to do.
There's one other test like that we have to describe it. There's 3 transformations we have to describe.
Okay, so obviously we're not going to do any extra practice today, but just a couple reminders for tomorrow. Homework, 3.4 to 3.6 reference sheet, and the test review.
Talking to you guys.
We'll have it on Google Classroom.
Still like 3 or 4 minutes.
Okay, both Mr. Roy and I are after school today. He's downstairs in 225. I'm right here. Okay, tomorrow is our second test of the quarter, and that's the only other test I have for progress reports, okay, because those close on Friday, okay? Your shop week, you still have one more shop week, but this is the last academic week.